The voltages employed in the following are sufficiently high to endanger human life. Every reasonable precaution has been observed and designed to safeguard the wiring personnel. Watches and rings should be removed when working around machinery and electricity. Wiring personnel should be prohibited from tampering with protective devices. The power should be removed completely before making adjustments. Be prepared in case of an emergency. Make sure you know how to treat someone for electrical shock and how to perform artificial respiration. Only qualified personnel, Electrician 614 or someone from the Fire Control Systems Trade Group are authorized to make connections to electrical panels powered by generators. An effective operational power supply is essential to the setup and running of any field camp. Careful planning, preparation, and maintenance are the keys to successful field wiring. Safety considerations must be foremost when you're working with electricity. In addition to discussing how to plan and implement field wiring, this video will show safe practices and procedures. Prior to going on any exercise, ensure that you have the required technical manuals for all the generators. You should also be aware of the general electrical requirements for the exercise. This will allow you to bring a sufficient quantity of connectors, plugs, sockets, switches, electrical panels, circuit breakers, and electrical cable. This video is divided into 3 modules. Module 1 is determining the power requirements and selecting a generator site. Module 2 is connecting the generator and balancing the load. Module 3 is hazards and safety precautions. These modules may be watched independently or as a group. Feel free to stop the video at the end of each module for review. Upon arriving at the exercise, the first thing you should do is contact the Camp Sergeant Major. Here, you must check the layout of the camp and identify what equipment will be used. From this information, you will then calculate the generator size, wire length, and peripheral equipment that will be needed. Once the initial assessment of requirements is complete, do a walk through the camp area to identify the exact location of various sections and confirm their power requirements. As you walk through, note special requirements such as whether the welders, the kitchen, vehicle technicians, and so on require 120 volts or 208 volts, single phase or 3-phase. In choosing a site for the generator, the ideal location is either an equal distance from all sections when the power draw will be similar in each section, or closer to the section drawing the heaviest amount of power when there is a large variance in power needed among sections. To minimize voltage loss, cable should run no further than 300 meters or 500 meters in the case of heavy cable. The site should also provide some type of concealment. Tactical situations will determine the amount of camouflage required for the generator, distribution panels, and boxes, and connectors. Remember, a lot of noise and exhaust are produced by a generator, so some locations, like near the soldiers' quarters, may not be appropriate. If the camp is permanent or semi-permanent, recommend sheltering the generator from severe weather. To help ensure a safe work environment, the shelter should be ventilated to avoid heat buildup and to allow exhaust fumes to escape. This will also make it easier to perform repairs and daily servicing. It is important for the generator to be sited on a firm, level foundation with good drainage. No smoking signs must be placed near the fuel supply and generator set. Once you have viewed the camp, you need to make a map of the field unit, identifying each area that requires power and how much power each needs. Add the wattage required for all lights and electrical devices. The total of these is the connected load and is usually measured in kilowatts. Remember, the actual electrical load will fluctuate as different pieces of equipment are started or stopped. This is called the demand load. The demand load is the maximum wattage required to serve a connected load. The demand load is usually less than the connected load because all the equipment seldom operates simultaneously. If they do, the demand and connected loads will be the same. Note that the demand load should never be greater than the connected load. You need to calculate the demand load to ensure power is being distributed efficiently. To do this, use the demand factors table. To calculate the demand load, first decide which demand factor applies to the area being connected. For example, the maintenance facility has a demand factor of 0.7. In the walkaround, it was determined that the maintenance facility had a connected load of 15 kilowatts. To determine the demand load, follow the formula. Connected load times demand factor equals demand load. The connected load is 15 kilowatts, and the demand factor is 0.7. Therefore, the demand load is 10.5 kilowatts. It is important to remember that this calculation is not to be used to determine the size of the generator. That is determined by the total connected load. The demand load is to be used for load balancing only. All areas to be connected must be calculated in this manner. When completed, this will greatly assist the technician in balancing the load with respect to the generator's phases. You must take voltage drop into consideration when planning a distribution system. The measurement for voltage drop, or line loss, is usually shown as a percentage of the voltage required at the receiving end. The maximum allowable drop is 5%. Remember, voltage drop will vary depending on your choice of cable size and the length of the cable. Refer to the Tables section of the current Canadian Electrical Code Part 1 Handbook to help you determine the correct cable size and type for each load. You can increase the voltage at the receiving end by increasing it at the generator set, but only to its allowable maximum output. An electrical distribution system is defined by the number of phases, the number of wires, and the voltages between the wires. In this case, the system has 3 phases and 4 wires, with 120 volts between L0 and L1, L0 and L2, and L0 and L3, and 208 volts between L1 and L3, L2 and L3, and L1 and L2. Military field units use a combination of 3 distribution systems. A single-phase 2-wire 120-volt system is used for supplying electricity for lighting in tents. A single-phase 3-wire 120-240-volt system is used to supply power directly to power tools and most equipment requiring small loads. And a 3-phase 4- or 5-wire 120-208-volt system is used to supply large amounts of power for workshops and hospitals. Sections may require either 120 or 208 volts. If the electrical panel has 4 wires, 2 wires are each single phase of 120 volts. 1 wire is the ground wire, which is green, and 1 wire is the neutral wire, which is white. This way, 120 volts and 208 volts can be available at the same electrical panel. Before starting the generator set, the load must be balanced. An unbalanced load will cause high voltage on the lightly loaded phase and low voltage on the other phase or phases. This will cause poor voltage regulation throughout the system. Also, a load that is unbalanced may damage the generator. To balance the electrical load of a 3-phase system, calculate the electrical load of each section, add them together, and divide it into 3 equal phases. As an example, this kitchen section, consisting of freezers, toasters, coffee pots, and kitchen machines, has a connected load of 10 kilowatts. Since the kitchen has a demand factor of 1.0, the demand load is 10,000 watts. To determine the current draw, divide the demand load by the voltage required. In this case, 83.3 amps. To determine the current draw for each phase of a 3-phase generator, simply divide the total current draw by 3. Thus, there would be a draw of approximately 27.7 amps on each of the 3 phases of the generator. Using the information from your meeting with the Camp Sergeant Major, other personnel, From your walk-around and from the diagram of the camp, reconfirm the connected power requirements and the size of generator you will need. Do not operate the generator set until it has been connected to a suitable ground. First, check your grounding rod. To make a grounding rod as efficient as possible, ensure it is clean, straight, and keep the point as sharp as possible so it more easily penetrates the soil. Typically, a grounding rod would be driven into the ground 2.5 meters or 8 feet. All connections should be clean and firmly tightened. Contact with the earth does not guarantee a good ground. The soil type, moisture content, and soil temperature affect the efficiency of the grounding system. Serious injury or death can result from operating an ungrounded generator set. In a semi-permanent site, have the vehicle technicians hook up an auxiliary fuel tank to provide fuel for extended running periods. Now that the generator is installed, you can drop off electrical panels near the various sections of the camp. Never attempt to connect or disconnect load lines to the panel while the generator is running. Ensure that all of your electrical distribution panels are of a weatherproof standard. In a semi-permanent camp, you should make maximum use of NSN 6150-21-875-8237 low power distribution and lighting set and NSN 6110-21-908-8306 portable power distribution unit. If a spool of multiple conductor cable is not available, it may be replaced with the appropriate number of runs of single conductor cable. Distribution panels not already incorporated into the generator should be bolted to a T-bar stake, which is driven into the ground. There should be sufficient ground clearance for all electrical drop cords, and the panel should be protected with a weatherproof covering. If cables are to be strung overhead, allow a minimum height of 6 meters for vehicle clearance when crossing roads. Use cables equipped with quick disconnects, such as twist locks, and if cables are suspended by poles or trees, adjust the positioning so the cable connections are supported. All power cables must be protected from mechanical damage by foot or vehicle traffic. If cables are to be run underground, dig a trench approximately a half a meter deep and either lay in sand or soften the bed so the cables won't be damaged. Use only moisture-proof cables and moisture-proof all quick disconnects by wrapping them with layers of electrical tape. Separate the cables to protect the circuits. Do not allow the cables to touch or overlap each other in the trench. Then, cover the cables with earth that is free of rocks and stones. Cables from distribution panels to outlets should be rated for extra hard usage with a minimum voltage rating of 300 volts and a minimum temperature rating of 60 degrees Celsius. Check your cable rating, which is printed on the exterior insulation of the electrical cable that you are using. See the table section of a current Canadian Electrical Code Part 1 Handbook for details. All cables to outlets or equipment that draw no more than 15 amps must be a minimum of 3-conductor number 14 AWG for 120-volt circuits and 4-conductor number 14 AWG for 208-volt circuits. A maximum of 12 incandescent lights or 8 duplex receptacles can be installed on a 15-amp circuit. For a mixture of lights and receptacles, the maximum total current draw cannot exceed 80% of the rated circuit breaker. All receptacles must be a minimum of 120 centimeters above the floor or ground. Weatherproof boxes must be used outside, but either weatherproof or standard boxes may be used indoors. For lighting, note the polarity of all light sockets before connecting. 2 conductor number 14 AWG black and white twisted pairs are normally used for inside lighting only. All cables other than power cables must be suspended from the tent structure and tied. Light sockets used to provide exterior lighting to a POL point must be weatherproof and not within 3 meters of combustible materials. Live cable should never be coiled due to inductive reactance. In a semi-permanent location with a large electrical load, a single large cable with 4 or 5 conductors is normally connected to the generator in the following manner. The neutral conductor, which is white, is connected to the lug labeled L0. The ground is green and is connected to the ground lug. The black wire is connected to L1. The red wire is connected to L2, and the last wire is usually blue, black, or red and is connected to L3. The opposite end of the load cable is hooked up to an electrical distribution panel, equipped with various sizes of circuit breakers and fused knife switches. This hookup is the same as for the generator. Make sure that the circuit breakers can carry the rated current and voltage needed by the drop cords. Once the load is wired to the generator, ensure that all the circuit breakers are off prior to starting the generator. Consult the operator's manual for the proper procedures to start the generator. If you are working in difficult weather conditions, such as extreme cold or heat, be sure to follow the procedures specific to those conditions. Once the generator is running and the load is switched on, check the output voltage and the current draw on each phase by using the ammeter and voltmeter on the generator or by using a clamp-on ammeter and voltmeter. The results of these checks will confirm whether or not your generator phases are balanced. If they are not, you must reconnect the loads so that each phase receives an equal load. For everyone's safety, notify all personnel before starting your daily inspection or any maintenance. Indicate clearly the time when the generator will be turned off, and if you leave the generator, attach a note indicating that work is in progress. Be prepared to make in-field wire repairs using a Western Union splice, a pigtail splice, a T-splice, a fixture splice, by soldering or using Burndy-type connectors. All joints should be protected from moisture by covering with electrical tape. The only successful field wiring job is a safe one. Injury to personnel or damage to equipment is costly. Be sure that everyone working with you is well aware of the appropriate safety precautions. Remember to wear appropriate safety gloves when working with electricity or pulling electrical cables. Also, be sure to wear steel cap safety boots. All electrical equipment must be properly grounded before use. For simplicity of repairs in the field, operators should use circuit breakers instead of fuses. Make sure to install the right size circuit breaker to provide safe, dependable protection. When refueling, always ensure you have an appropriate type fire extinguisher nearby and a drip pan under the fuel nozzle. Also, ensure that a proper static strap or line that provides a metal-to-metal contact between the refueler and the storage tank is used. If not grounded, sparks may be generated that could cause a fire. Electric shock treatment requires 2 tasks, rescue and revival. To rescue someone, interrupt the current to the location if possible. If this is not possible, use a non-conductive device such as a dry piece of wood to separate the casualty from the source of power, and then pull him to safety.
Help! I need help! Help!
Call or send someone for medical assistance. Check his breathing immediately. If he is breathing, check the pulse. If the pulse is irregular, monitor it. If there is no pulse, begin CPR. If he is not breathing, begin artificial respiration immediately and check pulse to determine if CPR is necessary. Safe and reliable field wiring is essential to the successful operation of any field camp. By following the steps outlined in this video, you can ensure that your camp has the power it needs so it can perform the task at hand.